1 second. Okay. All right, so you can see my screen, right?
Yes, sir.
Oh, okay. So today's session will be short. I'll just do a quick introduction to KiCad software. As you can see on my screen, I have KiCad 6.0. I think that's the latest KiCad out there. Anyways, you can download this from KiCad's website. It's an open source application. You don't need to stress yourself too much. You just download KiCad. You go to KiCad.org, download, and yeah, you just go to Windows. So what I've noticed about these servers is the worldwide server is very slow. So if you use this, your download might fail in between because of your slow internet speed. Maybe, yeah, that's if your internet speed is very slow. But what you can do instead is to use this feature where Austria. This one is very fast. I realize this is very fast. So whenever you're downloading this, try to use the feature where Austria instead of the worldwide OSDN. Yeah. So that's when you download this. It's like I think it's about 1 gig. So yeah, let me just try and download it. Yes, it's about 1 gig. Yeah, about 1 gig. Yeah, let me just cancel this. Yeah. So yeah, that's how you download KiCad. And then once you download it and you start it, you get this interface when you open KiCad. There are other things that gets installed along. You know, you have this PCB calculator, PCB image converter, and some other things. Yeah, but yeah, you can see everything that gets installed here. Calculator tools for calculating resistance, current capacity, image converter, convert bitmap images to schematic symbols. So this is what you use. For example, if you want to put a logo on your PCB, you can use this tool to convert the logo to something that you can drop on your PCB. Yeah, and then Gerber uses for viewing Gerber files. Gerber files is what you usually send to your manufacturer to manufacture the PCB for you. Yeah, so when you finish designing in schematic and PCB editor, you generate something called Gerber files. I'll try and do that if we have enough time. And then you have symbol editor as well. Yeah, so that's where you have your symbol library, where you have your library for all your components that you have inside KiCad. Yep. So for me, I usually start with the schematic editor. But before I even come to the schematic editor, I must have maybe decided on what I want to design, right? Maybe let's say I want to design a circuit for something. Yeah, let's say there's this circuit called push-pull. I don't know if you've heard about it before. It's called push-pull amplifier, this circuit. Yeah, it's something very interesting. I've done something on this before. It's quite interesting. So what you can use this, or what I used this to do then was to generate a, what do you call it? I think I used it to generate a square wave kind of thing. Yeah, square wave. Yeah, so a square wave that has like positive and maybe a negative part. A positive, how do we describe this? I can't remember exactly. But it has like a part that goes to maybe like +5 volts and another part that goes to like maybe -5 volts. So I can't remember what that is called, but I'm sure you get the gist. So I use this to generate something like a square wave to control another amplifier stage, and then that was connected to a wireless charging coil. I actually built a wireless charger with this. Yeah, I can't show you the circuits for that because it's company property, but yeah, this is something that's very cool if you learn about it. Okay, I think you also learned about 555 timer in the other class, right? In the other class by the other instructor. Oh, are you there?
Yes, sir. I'm here.
Oh, did you learn about 555 timer in that class?
Yes, sir.
Okay. I hope you understand it very well.
Yes, I understand it.
Now.
So what I want us to do is to try to build these circuits like this. Let me just you can see my screen, right? Let me just try to build this circuit. I try to build this circuit in KiCad. So I'll just be coming here and going back to KiCad. So this is a 555 timer based circuit. I don't even know what this does. Yeah, so this is this unstable? I don't know what configuration this is, but since there's a speaker here, it looks like it might be unstable. Maybe I'm trying to generate a sound, something, sound generators. But anyways, let me just open KiCad and then just design this. So this is schematic editor. Great, and I'll open a project. Oh, okay, I have to create a new project first. So I do file new project, and then let me save this in downloads. Okay, downloads. Yeah, so let me do 555. So that's the name of the project. So inside the project, it's when you create a project, it automatically generates the PCB file and the schematic file. But I'll start with the schematic file. You can also do the PCB directly. I think it makes sense to just start from the schematic. When you start from the schematic, you can easily go from the schematic to the PCB. You know what the difference, you know what schematic is, right? So schematic is like where you, yeah, schematic is, this is like a schematic. And then the PCB is this. All right, so the PCB looks like, yeah, things like this, they're the PCB. Yeah, this is the PCB. So you can easily generate the PCB from the schematic. Yeah. That's how I like to do it. I think some people design from the PCB directly. I might have done that too before, maybe when I was using Proteus. Designing the PCB directly. Not really advisable. So when you open this, so how do you get your circuits? Component or circuit symbols. So if you come to this, right, there are a couple of tools here. I will try and show you what some of them do. So this one here that says add symbol is meant for adding a symbol. So if you click that, it will open the symbol library, and then yeah, this takes some time to do. Okay. So the reason I'm bringing all these things is because I'm just using KiCad on this computer. This is a new computer somehow. So that's why it's bringing all of those stuffs. It's taking time to load. Let's see. Okay. Oh, I think my PC is hanging, which is strange anyways. All right, so then it brings this library, then it says choose symbol, 17,163 symbols loaded. Interesting, that's a lot of symbols. So I can just search here for 555. Yeah, so then you can see here that it brings LM555, and then it has some other versions of 555 timer. And then if you also look at it very well, if you look at this place, you can see the package type. So there are different packages for electronic components. I don't know if you know about that already. There's like something we call surface mount packages, and then there's another thing we call like true hole packages, and then there are a couple of other packages along that line. Well, I think I should probably just show you with true hole package first, since we just getting into this. How do I? Okay, let me just push this here, and then let me show you what difference between true hole and so true hole. Exactly. So true hole components are the components that go through your PCB to the other side usually many times. So if you insert it from one side, you have to solder it from the other side, something like this. These resistors, right? If you turn this PCB to the other side, you see that the legs of this resistor are going through the other side. But surface mount stay on the same side. Like everything about the surface mount is on one side. Something like this stuff here, the one on the left. So you solder that component on the part where you place, on the side where you place it. So I think both of them have probably have their own advantages and disadvantages, but I think true surface mount is like when you look at some of the sophisticated printed circuit boards around you, you find that you find these kind of components, maybe the two types in there. But what I've also noticed is that these days surface mount components are more common on those printed circuit boards than true components. It looks like the world is going fully surface mount. I don't know anyways, that's just from my own experience. Yeah, so if you look at this circuit here, you can see this is a true component, true. I can't see any surface mount on this board. Yeah, this looks like a fully true. Yeah, so this also explains this stuff. So this is the surface mount package, and then this is true package. So there's like the major difference between them. You can check out maybe the advantages and disadvantages of the two later. Yeah, later. So what other things do we need for this circuit? We need capacitors. I can see some capacitors here. Capacitor. And then we need resistors as well. So we just have to oops. Right. So this is unpolarized. Oh, let me so this is unpolarized capacitor, and then this one says polarized capacitor, and then this is unpolarized capacitor, small symbol, and then polarized capacitor, small symbol. So looking at the circuit, I can't really tell which is polarized or non-polarized. It looks like all of them are. Usually this is simple for polarized capacitor.
But that situation should be maybe not polarized. I maybe the switch should be non-polarized because the capacitance is very. The symbol might be polarized, but maybe because of the capacitance value.
Oh yeah. That's true. You're right about it. Yeah, I think they are polarized. Yeah. And then also this curve, I think they use this curve to also denotes polarized capacitors. So there's like two types of. There are multiple symbols for capacitors. I know there's one like if you do like this. Let me just draw this. If you do like this, and if both of the lines are straight like this, then this unpolarized. And then if one line is curved and the other line is straight, if one line is curved like this, yeah, I think the curved line denotes the negative terminals. Yeah, so this is like polarized. That's another thing I think they might be using in that circuit anyways. Yeah. But you're also right, the values are very small. Those usually non-polarized capacitors are bigger, they are smaller. Sorry, these values are very big. Non-polarized capacitors are ideally smaller than this. So let me just pull non-polarized or polarized capacitors. Small. So the difference between the small and the one that does not have small is that this is smaller when you put it inside your schematic, and it doesn't take so much space, unlike okay, so we have 3 capacitors and then resistors as well. Resistor. How small US, so you can either use the US symbol or you use the generic symbol. And so let me just use the US symbol. And then we also need, I think we also need the potentiometer. This is a variable resistor. Variable resistor there. Where is that? Oh, I actually found that earlier. Okay, potentiometer. So okay, let's just save this. All right, so that comes in here. All right, I think that's all we need, and then we need a buzzer here. Buzzer is the buzzer or buzzer. Yep, we found it, and then yeah, that's also sits here. And yeah, I think that's the major components. So we just need to arrange things now. So all right. Cool. So we can close this and then switch. You can switch back to your select item tool. So now you can move things around. It's the select item tools. So yep. Then we can start to connect things together. And then I think we have 3 capacitors. So you can do, if you right click on this, you can do Control copy, Control C, or you can tap Control C and then press Control V to paste. Yeah. So that's 3 of those. And then we have 2 of these. Yeah. 2 of the resistors. Control C, Control V. And then, yep. So between pin 6 and pin 2 are connected. Between pin 6 and pin 5, you have one of the capacitors, right? Pin 2, 5, or 6, 5, you have one of the capacitors connected. So let me just do this. Okay. So that's 1 microfarad, right? So if you come to the top of this capacitor and you press V, and when you press V, it brings this. V is a shortcut for changing the value. So you can just press this here 1U. And once you press 1U, it changes the value to 1 microfarad here. So V is one of those very useful shortcuts. So you don't have to right click every time that you need to change the value of a component. And we also have something going between from pin 5 to ground. From pin 5 to ground, you have a capacitor. Okay, so let's take this here. I wanted to do V. E is another shortcut, but when you press V, and what's the value of that? 0.1. 0.1, just 0.1. Okay. 1. Yep. And both of this, the end of this and the end of this, are connected to ground. Let me shift. Oops. Just a little bit. All right. So once I place my cursor on top of this circle here, can you see? Once the cursor comes to the top of the circle, you see this green symbol. So that symbol is for wiring. It tells you that you can wire that point. Yeah, you can, if I come here now, you can see I can wire this to something else. So that's one thing. And if you don't want that, you can always come here to add a wire. Add a wire option here on the right side. And then another shortcut for that is you can press W. When you press W, it just starts wiring. Yeah. So you can come to this point and then maybe press W. Yeah, when you press W, then you can wire that. But it's also, I think a new feature is, this one is a new feature that once you put it on top of the, even when you're in the select option, once you place the cursor on top of this circle, then you can wire directly without any extra commands. So what else? Ground is connected to ground. So these are things, they are all connected to ground in a way. Okay. All right. I think you notice is pin 4 is connected to pin 8, like this. Let me just pin 6 and pin 2 are also connected So I'm trying to keep things as neat as possible. Okay. So I can just take this and then maybe take this way. And then maybe just connect this to this point. Maybe not the best. It does the job. I'm just trying to keep everything neat. I don't like it when wires starts crossing over wires. It can get. So let me put this resistor here. So you can use the R shortcut to rotate in case you need to rotate. In this case, you can just press R while placing the cursor on top of the component. And if I place the cursor out, but because the component is selected, yeah, it still works. But if I don't select the component, I can still rotate with R. So that's something, another shortcut you should note. So that goes to ground. Like this. Oops. Let me shift this a little bit to the side. So as you have this register 1K. So do V1K. Alright, so the place here. Then positive and then to negative goes to ground. I'm still going to have to cross these wires at the end of the day. Right, goes to ground. Okay, 7 is going to okay, so 500K resistor between pin 2 and pin 7. All right, so this is value 500. If you have any question, you can ask. And then top of this goes to pin 7. Okay. So you have another 1K up here, which now goes to 2. Yes, if you come to this symbol here, that's a power symbol. This ground looking symbol, if you come here, you can find 12 volts here. It's 12 volts. I can put 12 volts somewhere here, and then I can put ground somewhere yeah. Yes, you can use sound, right? There's actually a difference between arts and ground. I can't remember the difference, but anyways, let me just use ground in this case. And then okay, let me just leave this unwired directly from here. Okay, yep, ground is wired. I don't have anything. Okay, so we have this going to this point and then going to 12 volts. All right, and then you also have something happening between pin 8. Okay, pin 8 is directly connected to 12 volts. And then pin 4 is also connected to the same point. All right, so you need to notice that this line is crossing these two lines, right? But the way you know if a line is connected to a line is crossing over is if you have these dots. Yeah, so if this dots means connected, but if you don't have this dot, that means they are not connected. This one going this way and this one going this way, they are not connected. We are almost done, and then we need 100 microfarad from 12 volts. Yeah, so this is going to help us do. So I can Control C, Control V, ground here, and then 100 microfarad. So it should be. Oops. Cool. I think we're done. Yeah, fine. Looking good. All right.
Sir, just finish.
What did you say?
I gotta have a question.
Oh, go ahead.
Okay, the variable resistor we have there. Yeah, I
Oh,
want
yeah.
to ask, why didn't we connect that pin 2 to
Oh, that's a mistake. I actually forgot it.
so that?
So that's why I add this to this pin. Oh, do you understand this, right?
Okay, yes. But is there still need to still connect it to 3, or we can connect that 2 alone, but it must be connected to that pin 3?
I didn't get that.
Like, there pin 2. That
Yes.
when we are bearing the resistance, that is where we have like that with that pin 2. But I said, is there need to connect that pin 2 and 3 together to themselves, or we can just connect 2 alone, or it must be connected together?
Yeah, you can just connect 2 alone actually.
Okay, no, let's confirm.
Yeah, you can connect 2 alone. Yeah, I think so. You know the way it looks is looks something like this. Let me just pull this. So what you actually have is the variable resistor looks like you have a maybe how do I describe it? Yeah, it's like you have a resistor like this, and then you have something that's moving. This is moving. It's moving, right? This is moving up or down. So if you connect it, if I left the connection the way I left it earlier, like if I leave 1 and 3, then that means I'm not actually varying the resistance. So you get. So, but if I connect, this is 2, right? If I connect 2 to this point, so it's almost like I'm shorting out this part, I'm shorting out this part, and I'm just following whatever this does anyway.
All right.
Yeah, so wherever this goes is what the resistance would be at this 2 connections. Yeah. So just like you said too, we could leave 3 out. We could just remove 3. We could remove the 3 parts and then yeah, we could just leave the 3 parts and just connect 2. And that also works. Yeah, that also works.
Thank you, sir.
All right, so that's like how we have to do here. But before we go to the PCB, we have to do something called annotation. As you can see, like these resistors are not labeled. How do you know which is which? For example, we have multiple capacitors. How do you know which capacitor is which capacitor? Especially when they have the same values. And then so all you do is there's something called annotation here, feeding schematic symbol. This one. I think it's this one. Oh yeah. So once you open this annotate schematic stuff, and just click annotate, and then it just annotates everything for you. So there are some other settings you can do here for the annotation. Yeah, there's sort symbols by exposition. Yeah. Once if you change this, then you get a difference. You can actually get a difference results depending on what you're doing. You can explore some of these things later. Yeah, but I don't want to get into that much details. And another thing that you can do is there's something called electrical rules check. Okay, so it says input power pin not driven by an output power pin. Input power pin not driven by any output power pin. So I think this is just speaking some word errors. Yeah, anyways, let's just continue. And something else you also need to do before going to the PCB is to run footprint assignments too. So footprint assignments is, these are actually schematic symbols, but yeah, you need to assign a specific PCB package type before going to the PCB editor. So for example, let me show you this. If I view these currents, you can see that this is the footprints assigned to the 555 timer. So if you want to understand how this looks better, you can click that 3D symbol. So if you click the 3D symbol, you see this. You can actually see that, oh, this is a true O component. Yeah, and this is how it's going to look when I finish manufacturing this. Yeah, so this is a true hole part, but you can actually change this to a surface mount part as well in this interface here. So if I go to register, but for these other ones, they are not, or they were not automatically assigned, so we need to assign those ourselves. So let me just so I can, this is the buzzer, and what we can use for the buzzer. I think the buzzer is just like, just have a 2 terminal or something. Let me see. I don't think I've designed for a buzzer before. Oh, okay, buzzer beeper. Oh, interesting. So they have like packages for this as well. Oh, nice. So you can check each one of these, and you can view selected footprints and see how it looks in 3D to confirm if it's the actual type you have. So let me see, indicator, buzzer. I don't know which one is which one. Yeah, there are buzzers that look like this. We can just select this one, actually. Yeah, but you have to be sure what you're selecting when you are doing your own design. But because this is just a random design, I'm just selecting that. So also you go to capacitor, we have different types of capacitor. We have axial, we have radial, we have disc, we have rectangular capacitor. So you have to look for the type that you're using. I think we usually use maybe radial. Yeah, we use radial most of the time. Yeah, so they look like this. And then you can select a particular package type you have. I don't want it to be too big. Let's select 5 mm. Yeah, I think 5 mm should work here. So 5 mm capacitor. Let me just select the same thing for all of them. And then resistor as well. You come to this left, you go to footprint library, go to resistor. Resistor true, THT means true, SMD means surface mount. True, I think it means true type or something. I can't remember. So we also have axial resistors. Axial resistors look like this. Yeah, you know this. I'm sure you've seen this before. These are very common resistor types. So this is probably what you would use as well. So let me just select 3, and then you double click to select a particular one. You double click. Yeah, so then this is for the variable resistor. For the variable resistor, we have to go to potentiometer, true type, and then go to, I don't really know this as well. Let me check. Blueprint. Yeah, so this is one type, and then that's bonus. So there's another type called apps. These are these complex resistors. So there's another one called issue package. All right, so I think the one that I will be using is the bonus. These guys. Oops, no, not this. I selected that one area. I can't remember what it is. Oh god. That was the first one I actually selected. Oh, this is another type of variable resistor. I think I've used. Have I used this before? No, I've not. Yeah, but this is another type of variable resistor that you can use. This is complex. I can't remember the one I selected the first instance. I should have just assigned it. And let me just use this and assign this one. So this is also a variable resistor type. It's definitely not as cool as the NEC single C. I don't want to spend too much time on this slide resistor. Okay. What? Oh yeah, so it's another type of variable resistor. Let me just use this one. Like contour with your screwdriver. Oops. All right. So apply, you do apply, save schematic and continue, and then you okay. So once you do that, you assign PCB footprints to each of these components. Then you can either click this symbol here, open PCB board editor, or I think you can do it's another way to do this, maybe yeah, tools, and then you do tools, and then you do switch to PCB editor. Yeah, from there. So it takes you to the PCB editor, and then when you get here, you can just do click on this button here, update PCB with changes made to schematic, and then it asks you these weird questions, and then what's this asking you? Update PCB from schematic. All right, so update, and then close it. So it's going to ask you to drop this wherever you want to drop it, and then just drop it there. So this is the way the PCB editor looks like. I'm running out of time, so let me just quickly run through this. So this is the 555 timer, and then this is the variable register. Yeah, so this requires some of practice to to become very good at this. I'm just going to try to drag things around, and so I try to keep things as close to their connection points as possible. So you can see this is connecting to pin 6 and ground. So let me just take it to this side. Pin 6 is here. The R. Push this aside. Okay. Oh, the buzzer is very big. Okay, this is massive. Okay, this is register from here to the buzzer, and then capacitor here connected between pin yeah, ground. All right. And you can see this as well. This is connected between pin 4, 12 volts and ground. Yeah, you can keep it this way. Usually, you want everything to. You don't have to do everything to face in the same direction, but usually it's neat when everything is facing the same direction. And this is connecting between the pin 8 and yeah, so it's better for this to stay here. I'm having an issue with this right now. The issue is that everything is snapping to something else. This is not the best of designs. But anyways, I think it will serve our purpose. So you can, everything is snapping. So what I can do is you can see if I try to move this left once, it jumps. You can see that it's jumping. So to fix that, you can go down here. You can go here and change the grid to maybe something smaller, like 0.5 millimeters. So, yeah, now I can move it with more flexibility. So that's something you can do. We'll have another meeting in 10 minutes. So let me quickly run through this. All right, so I've arranged the component. It's not usually this easy. So they expect it to always be easy like this. Yeah, it's usually more complicated than this. But anyways, yeah. So these are the different layers you have in your PCB. These are the different layers you have in your PCB. You can probably read about this. I think I shared some videos on this in the PDF I shared. Yeah, so when you go through those videos, I'm sure you understand this better. I'll also try to share some other links for you, to you, so you can, it's you, so you can understand this stuff better. Yeah. So these are layers I can. So if I want to wire this, I have to wire this on a particular layer, but because these components are true or components, I have to wire it on the bottom layer. So I can just, wire this, and then something like this, and then this comes down like this. There are also rules you need to follow when you are designing this, so usually you don't want things to be very straight. Yeah, like this, you don't want straight stuff from here to here. There are rules regarding those things, like be like rule of thumbs or something. But when you study this better, just like I said, I'm sure you understand those things better. I can't cover everything in this tutorial, in this session. Yeah, I'm just doing a quick intro. All right, and then this is ground. This is ground, and then this is 12 volts. Oops. And then this is connected to this. All right. Now I'm facing a problem because this is crossing this. So one way to fix that is one way to fix that. Okay, let me just connect the other one first, and then we deal with that later. Okay. So, yep. And then the ground here is connected to the ground here. Okay, so this can go through underneath this. That's one thing about this. So, and then it comes here. And then there's one more connection that needs to be done that is not done. So these white lines show the connection you are yet to do. So we need these 12 volts here to connect to these 12 volts here. But as you can see, there's almost no way for me to get here without crossing anything. Yeah, that's a problem. So how do you fix that problem? That's one thing you run into when you don't arrange your components very well. Yep, that happens when you don't arrange your components very well. So one thing I could do is interesting. Not so cool. So there's something called vias. I can use vias to move this around. So let me just route this from here and then take this here, this way like this. And I can use something called vias to transfer. So if I right click, then you see something called place through via. So what that does is like it takes me to another layer. It takes me to, I'm actually routing on the bottom layer, but it takes me to the first top layer. And then I can route from the top layer. I can route it on the top layer and then maybe place through via again and jump back to the bottom layer. Place through via, and now I'm going back to the bottom layer. And voila. Yep, that's connected. You usually don't want to. Oh, what did I just say? Oh, I connected to the wrong port. Oh God. I think I actually connected that to the wrong connection. Oh, I was going to 12 volts here. Sorry. Let me just do that again. So I can come here, right click, place through via, and then come here this way. Come here like this, and then right click, place through via, and then you can see it's jumping around again. That's because of the grid. Anyways, let me just drop that. I thought this was going to 6 volts. Why is it acting weird? Oh, I was connecting the wrong thing. Sorry, excuse me. I forgot that this was already connected. I actually wanted to do for 12 volts instead. So let me just connect. Let's go. And then I can come here this way. And then come here, place through via. I usually don't like to use vias. I mean, when I use via, it's almost like I feel like I didn't arrange my components very well. And then when you're done, you can also add like you can add edge cuts. There's something called edge cuts. But before you add edge cuts, you have to switch to the edge cuts layer. I think there's an edge cuts layer. So you can switch to edge cuts from here. Yeah, you just switch to edge cuts and then you click on rectangle or circle. You can even make it in form of a circle. You've seen those nice, I'm not sure if you've seen those nice circular PCBs. I can show you one that let me see if I will be able to show you one. Very, very nice PCBs. So that's it, and you can edit the thickness of this. Maybe change this to maybe 0.5. Are you following? So can you see how
Yes,
it
sir.
looks in 3D? Yeah. So this was our via connection I made. The one I took to the top layer.
But
I didn't
answer the
get it.
question now. Okay, I thought I want to ask you a question. So we have different type of PCB. There are some PCBs that are just one layer, maybe just bottom.
Yeah.
Like that is where the connection. So in this kind of scenarios, and there are I think some complex circuit boards that everything they will do is just in one layer, and it's two whole component they use. I do wonder that how will someone let's say one is to use one-sided PCB that we are not going to do any connection on the other side. Is it possible?
So if you are using a one-sided PCB, can you see this connection? This kind of connection I have here, you can actually use a wire to do it.
Okay.
Do you understand? You can just put the wire here, solder it, and then put the wire in the other place to solder it.
Oh, that is excess of unnecessary wires.
Yeah.
I get that. You won't just use like a connector or something like a header. You plug it
exactly. Yeah. You can use stuff like that. So this is how it looks in 3D anyway. Yeah, I have to go now. I have another meeting I need to attend, but I'm sure I've explained some of the fundamental things that you need to know. There are some really cool stuff that you need to learn. I'll share some videos and some files that would guide you guys on how you can go about this, and then maybe I'll also give some assignments or some tasks to you guys so you can do something. If you have other questions, maybe you can ask on the chat or something.
No questions. I said no questions, sir.
Oh, okay. Thank you for coming. So I'll share the video too once it's available.
Okay, all right, sir.
Right, see you later.
Yes, sir.
Bye-bye.